Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, every week we profile some of the most amazing, jaw-dropping developments in science and technology. And today we're going to bring on a 30-year veteran of the United States space program, talking about a new Disney Plus show produced by National Geographic and also Leonardo DiCaprio's Appian Way. It's called The Right Stuff. And we're going to relive some of the glory days of the early days of the space program back in the 1960s. You know, many people think that with SpaceX, we're entering a second era in the exploration of outer space. NASA has juice once again as it explores the moon, Mars, who knows. But what about the first? What about the beginning of the first era of the space program? That's what Tom Wolfe's best-selling novel, The Right Stuff, is all about. It's about John Glenn and Alan Shepard, two names which everybody knew back in the 1960s because it was a race against the Russians. So once again, it's going to air on the Disney Plus channel produced by National Geographic. The title, once again, is called The Right Stuff. But with us today is Robert Yowell, 30-year veteran of the United States space program, a graduate of the University of Southern California and the U.S. Air Force Institute of Technology. We should also point out that he's no stranger to interacting with the public. He's a technical consultant for Hollywood movies, including Ad Astra, starring Brad Pitt, and also Lucy in the Sky. And currently, he's a technical consultant for The Right Stuff, talking about the early days of the space program. Well, Robert, you're a 30-year veteran of the U.S. space program, but tell us, when you were a youth, when you were a kid, what steered you in the direction of science and eventually the space program?
Well, Dr. Kaku, I can tell you that you, as well as Carl Sagan and so many others that I watched on television as a youngster, were a great influence for me. So it's a pleasure to talk to you today.
Thank you.
You know, the single spark that really ignited me was in 1971. I was 4 years old, and the Apollo 15 mission to the moon was happening that summer. And that particular mission had quite a bit more television coverage than usual because it was the first time they carried the lunar rover to the moon, which had a separate television camera that could be controlled from the ground. So there were many, many hours of coverage, and as a 4-year-old kid, I was glued to the television that week for that mission. And that, for me, was truly the spark that ignited my interest. Growing up in New York, the closest I came to seeing real rockets was the Flushing Meadows Park in Queens. And when my dad would take me to a Mets game, we'd go across the street to look at the Atlas and Titan rocket there, which is still there today. And again, that was a great, great spark for me. So from that point on, I think I ate, slept, and drank space for the rest of my life.
Okay, well, let me ask you a question that a lot of kids ask, and that is, how do I apply for the space program? Do I go on the email and send nasa.gov an email request? How do you become an astronaut? What are the steps?
Well, becoming an astronaut, of course, is a little bit more difficult than just working in the space program. So let me take the two of those a little separate, if I could. It's a lot easier today to get involved in space than it was when I started, because as you mentioned, there are so many more players in it than just NASA. So, for instance, SpaceX, Boeing, Lockheed, they all have tremendous intern programs for college students, which can be applied to directly, I'm sure, through their website. So the Internet has made it much easier today than it was when I was a teenager and had to literally write letters. Now, as far as being an astronaut, of course, NASA has many outlined requirements for that. in the latest round of those requirements, it does require a master's degree. So obviously, it would take some time for someone to reach that point.
Okay. Now, The Right Stuff is based on a novel by Thomas Wolfe, bestseller, about John Glenn and Alan Shepard. Everybody knew their names back then, but paint a little picture for us. Paint a picture of what it was back in the 1960s when space was so mysterious and so unknown, and we were in a race with Russia. And I still remember people writing fearful letters to the editor saying, what happens if the Russians put hydrogen bombs in outer space and destroys the U.S. from space? Well, give us a little picture. What was it like during the Right Stuff?
Well, really, it was the Cold War. And, of course, the Sputnik launch in 1957 was a tremendous shock to the United States. And as you just said, it grew fear into people, into politicians as well, that, my gosh, if the Russians can put a satellite in space, they can put a nuclear weapon directly aimed at us. So that really is what began the space race for us to catch up technologically to at least meet the ability of the Russians have proved. Now, taking that a step further, 4 years later in 1961, yet another shock with the Russians putting Yuri Gagarin into orbit. And in April of 1961, we had just reached the point where we were just about ready to put Alan Shepard into a suborbital flight. But in one fell swoop, in that day, in April of 61, the Russians again passed us in that race by putting Yuri Gagarin in orbit. It would take us almost another year for us to put John Glenn into orbit. So this was a race of technological superiority. How are we going to do that? How are we going to meet that challenge? Well, it took, of course, the leadership of President Kennedy to make that happen. And, of course, it took a lot of the United States budget to make it happen. But I think all would agree this was a good kind of race because it was, in the end, for peaceful purposes. And look at all the scientific knowledge we gained as a result of it.
Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Robert Yowell, a 30-year veteran of the U.S. space program, and he's been a technical consultant to a number of Hollywood films, including Ad Astra, starring Brad Pitt, and Lucy in the Sky, and now he's a technical consultant for the new Disney Plus program, The Right Stuff, based on Thomas Wolfe's best-selling novel about the early days of the manned space program. You know, many people say that we're entering the second era of the exploration of outer space. All of a sudden, we have Silicon Valley billionaires jumping in, opening up their checkbooks. All of a sudden, we have visions of going back to the moon, on to Mars, and beyond. But the question that we're going to ask today is, what was it like back in the 1960s when the United States was, well, humiliated by all the failures of its space program, how the Russians put the first satellite into orbit, the first human into orbit around the Earth, the first dog in outer space, the first object to strike the moon. It goes on and on and on, all the Russian firsts. Well, once again, with us today is Robert Yowell, 30-year veteran of the U.S. space program. And we're talking to him about the early days of the space program. So, Robert, tell us a little bit about who is John Glenn and Alan Shepard. Who are they? What were their backgrounds? And I guess there was a little bit of rivalry between them as well.
Well, of course, John Glenn and Alan Shepard were just two of 7 astronauts who were selected by NASA in 1959. And the book, The Right Stuff, as well as our series, focuses on all 7. 7, actually. It's not only Glenn and Shepard, but of course, Glenn and Shepard became the leaders, if you will, of the pack. They came from different backgrounds. John Glenn was a Marine Corps pilot, test pilot. Alan Shepard was a Navy test pilot. They had each different experiences prior to getting to NASA. Many would say that John Glenn had a bit more refinement in terms of his public, his ability to work with the public and public affairs and speaking engagements, because John Glenn had already become somewhat of a celebrity. He had set the coast-to-coast record for jet flying a few years before becoming an astronaut. John Glenn appeared on game shows like Name That Tune and the Today Show and places like that. So he was already somewhat in the public eye. The other 6 astronauts, including Alan Shepard, were not. And as you might see in the series, Alan Shepard didn't quite have the sense of how the press would treat his family and his personal life to the degree that John Glenn already knew. So I would say that John Glenn had an easier time being in the spotlight than the other 6 astronauts. And I understand, since we're all human, there was a little bit of rivalry between them about who would be first to go into space, first into orbit, and that rivalry extended all the way to the moon when our lunar astronauts debated who would be the first to step on another celestial body in the universe. So tell us a little bit about the dynamics of these people. These people were veterans of the military. They were hard-nosed realists and trained really hard. What was it like, the interaction between these astronauts? Well, more importantly, all 7 were test pilots. And really, you have to treat test pilots even as a separate category than the rest of any military pilot. They're a breed of their own. They're extremely competitive. And, of course, they know how to deal with the unknown. They know how to deal with stress. They know how to deal with complicated machines. And that's exactly why NASA selected them for this job. And because of that competitiveness, sure, if you put 7 people in the race to be first in space, you're going to have heavy competition and rivalry and some rough edges. And that was definitely the case. And also, let's talk about the rigorous training involved, because these are the cream of the cream of the cream in terms of physical fitness. Some of us have seen the movie Apollo 13 with Tom Hanks. Tom Hanks was, to train for that film, put into an airplane that went into free fall to create the simulation of weightlessness. And it's called the vomit comet because everyone throws up because you get a feeling of dying, of falling and death, and you throw up as a consequence. So tell us a little bit about the training that these astronauts had gone through, especially given the fact that we were making it up as we went along. These were the first. That's right. And as a matter of fact, the Vomit Comet, the KC-135 aircraft that you mentioned, was flown by NASA well into the early 2000s. But prior to the KC-135, there were other aircraft used for the same type of parabolic flights. And in fact, the Mercury 7 were the first to fly in that configuration. So the Mercury 7 all went through that same zero gravity experience training. And that was probably the most comfortable of all the other training they had, believe it or not, because they also had to go through centrifuge training, which is quite intense. And today we don't necessarily do that with our astronauts. They went through some very, very extensive medical examinations, which, again, were above and beyond what we do today. So they were truly guinea pigs because in reality, many, many doctors thought that your digestive system wouldn't work in microgravity, your circulatory system would go haywire, you'd even lose your vision. So because of all these unknowns, we had to ensure that these men would at least endure the duration of the flight and be alive at the end of it to at least tell us what happened.
Okay, and tell us a little about what it's like to actually be up there in outer space. Now, these astronauts, of course, only went up, came back down again within a matter of minutes to hours, but our astronauts stay up there for months at a time. So what was it like to be out there? For example, food. What kind of food do you eat, given the fact that everything floats and you can't drink water because, of course, water will also float in weightlessness. So what is it like? Do they really simply suck concentrated vegetables and nutrition, or how do you eat in outer space?
Well, actually, you can drink water. They drink a lot of water in spacecraft, so it's obviously done through a straw. You can't have an open container with liquid because, as you alluded to, liquid would just float around. But today on the space station, we have gourmet meals practically on board. It's come a long way from the days when John Glenn had to just eat applesauce through a straw. So for the very early NASA missions, the Mercury, Gemini, and then into Apollo, it was pretty much your bite-sized cubes of food or dehydrated Tang, the powdered drink that you'd have to add water to, and then you would sip it through a straw. So today, your meals on the space station are eaten with a fork and a spoon. Carefully, you have food that will cling to those utensils, and it's actually not a bad experience. Your taste sensation, however, is quite different in space because all the blood and fluids rush to your head. You feel, at least for the first few days on orbit, sort of like a sinus cold, and you lose your sense of taste. And for that reason, you'll see a lot of astronauts taking a lot of hot sauce with them into space, just to spice up the food so it doesn't taste so bland.
Okay, now let me ask you a question that every kid wants to ask somebody who's been with the space program, and that is, how do you go to the bathroom in outer space? Is there some kind of suction device? I mean, every kid wants to know before they blast off themselves. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Robert Yowell. So we're talking about the beginning of the manned space program. Many people think that we're entering a new phase in the exploration of outer space. Rockets can be reusable now. Prices are dropping like a rock for launching payloads into outer space. Private enterprise billionaires are opening up their checkbooks in order to help fund many of these futuristic adventures. And a new vision is coming out with Elon Musk talking about becoming a multi-planet species, and with Jeff Bezos, richest man in the world, talking about creating the Earth as a celestial garden, putting all the dirty, polluting industries into outer space, and the Earth would become a jewel, an ecological jewel, a Garden of Eden floating in the heavens. But let's not go back to the early days of the beginning of the space program. So the series is called, The Right Stuff is the book, and it's about John Glenn and Alan Shepard and the other brave astronauts who paved the way for the space program. Well, Robert, when we last left off, I have to ask you this question. Every kid wants to know the answer to this question, and that is, how do you go to the bathroom in outer space?
Well, of course, the answer is very carefully. But today on the space station, there is actually a toilet. And we had a toilet, in fact, on the space shuttle. So you have to allot enough time, though, in using it to ensure that it's clean and ready for the next person to use. So all you can say is everything floats in space, including what comes out of you. So when you're using that toilet, you have to ensure that you have a proper seal between you and the seat, and then you push the button in the case of the ones we have today, and a suction mechanism takes the waste out of the toilet and into a tank. Now, the astronauts, of course, on Mercury, Gemini, and Apollo did not have that luxury. Basically, you had to, if you had to defecate on the Apollo program, you had to essentially attach a bag to your backside and do your thing, and then seal up that bag, which contained a germicide and deodorizer, and that bag stayed sealed up in a storage container in the spacecraft. So there was no ejection mode for that. But for liquid waste, it was a lot easier on Apollo and the shuttle. You could basically dump that overboard. And as astronaut Wally Schirra said during Gemini, when they did a urine dump, it was the constellation Uriah coming out. Because, of course, all fluid that goes into space in a vacuum becomes a spherical particle. So they were kind of creating their own little stars whenever they did that.
Welcome back to Science Fantastic with Professor Michio Kaku. Our special guest today is Robert Yowell. Well, when we last left off, we were talking about some of the glory days of the beginning of the U.S. space program. It was a national emergency trying to beat the Russians to the moon. But of course, let's face it, it's also dangerous. And there were hazards involved. Three of our astronauts burned to death in an early accident in the U.S. space program. And since then, we've had two, not one, but two space shuttles blow up. Television, a horrible cathartic experience. And you have to realize that on average, if you do the numbers, on average about 1% of our rockets will blow up, sometimes carrying the humans with them. So tell us a little bit about the dangers. Did we really understand the dangers of space travel back then when Gus Grissom and two other astronauts died in that fire? And what about the accidents that have taken place since then, right?
Yes, well, in the Apollo 1 fire that you're talking about, which happened in 1967, we were using a pure oxygen environment, even back in the days of Alan Shepard and John Glenn and Mercury. The atmosphere inside the spacecraft was pure oxygen. That was a somewhat simpler way of handling the process of pressurizing and depressurizing the cabin. However, what happened in 1967 with the Apollo 1 is we pressurized that capsule to sea level pressure with pure oxygen inside. 14.7 psi with pure oxygen is essentially like having a full tank of gasoline ready to explode with any small spark. And unfortunately, that is exactly what happened. And as a result of that accident, we never again did that type of ground test. And then later on, in the shuttle program, we actually didn't use pure oxygen. We used a mixture of nitrogen and oxygen in the cabin environment, and that is in fact what we have today on the International Space Station. As far as the two shuttle accidents, they were two different issues, but both of which were in some respects attributed to the design flaws that we had early on in the shuttle program. The Challenger explosion occurred because of the failure of a rubber O-ring seal in one of the solid rocket boosters, because the day the Challenger was launched was the coldest day we had ever launched a rocket into space, at least with astronauts. It was below freezing overnight, and it was just about above freezing when we launched the shuttle. So that rubber seal, of course, cracked, and the solid rocket boosters were just like a solid rod of gunpowder. You want to think of it that way. Once it's lit, there's no way to turn it off, and that flame would find any crevice or any hole to go out of. And what happened, once the seal was cracked, it created a cavity in the solid booster, and the flame was shooting sideways out the side, essentially tumbling the entire stack of the shuttle and everything else. And what you see on that television footage is not so much an explosion as it is an aerodynamic breakup of extreme levels. The Columbia accident happened because the external tank of the space shuttle had thermal insulation sprayed on the outside, and it was a type of foam. Unfortunately, that foam tended to fall off on many, many shuttle flights. Most of the time, that foam simply hit the bottom of the space shuttle's black tiles without any catastrophic problem. However, on the Columbia, that foam on launch hit the leading edge of the shuttle's wing, creating a hole in that leading edge.
To Science Fantastic with Professor Michio Kaku. With us today is Robert Yowell. Well, where we last left off, we were talking about the probability of, well, let's face it, your rocket ship blowing up. And there's a famous story. Richard Feynman, the Nobel Prize-winning physicist, once met with the top NASA engineers and bureaucrats, and he gave them a sheet of paper, each one, and he said, what is the probability of catastrophic failure of the rocket? Catastrophic failure. What's the probability? Most of the engineers said, well, 1%. That's roughly what happened. That's it, folks. About 1% of the time, 50 years into the space program, our rockets will still sometimes blow up. But one person handed a sheet of paper that said, never. Never. Those are the words he wrote down. And then the Nobel Prize-winning physicist said to himself, why? Why was this engineer saying that accidents can never happen? And then he realized this one engineer was promoted into the bureaucracy. He became a bureaucrat. A top engineer became a bureaucrat subject to political pressure, financial pressure, deadlines, not the laws of physics, but the pressures of the marketplace and everything like that. And that distorts your science. And so he said that in the future, scientists who do risk analysis should not be consultants to the government, should not have lucrative jobs. No, they should look at the math, the statistics, rather than the wishful thinking of bureaucratic deadlines. Well, Robert, let me ask you some questions more about the training of our astronauts. After 1 year in orbit, Russian astronauts who've come down experience enormous muscle degradation. Commander Polyakov, who has the world's record for being in outer space for over a year, when he came down, he was like a worm that could barely crawl on the ground, even after rigorous exercises on the shuttle. Some people think that some of our astronauts even experience permanent damage to their muscles and bone. So what are the hazards of, well, lack of exercise in outer space? What are your thoughts?
Well, it's very well known that it's a very serious concern. Not only muscle atrophy, but also decalcification of your bone structure. Because obviously in microgravity, you're not using your skeletal system to the degree that you are here on Earth. You're not putting weight on your bones. And what happens in our astronauts is we've seen the decalcification happening through their urinary tract. So all this calcium leaves your bones, and it leaves them quite brittle to the degree that you're almost, in a way, having osteoporosis. So every astronaut today on the space station has a mandatory 2-hour daily exercise regimen. And we've improved quite a bit the type of exercise equipment we carry today versus even the time that we were doing it on the space shuttle. So today's astronauts have a much better chance of recovering from the long-duration flights than ever before. And I would suggest your listeners pick up Scott Kelly's excellent book where he talks about his endurance. In fact, that's the title of his book, going through the process not only of being up there, but also his acclimation back on Earth. But besides the muscle and skeletal degradation, you also have an interesting byproduct of being in microgravity, because when you're wearing clothes in space, they're essentially floating around your body. Well, what Kelly describes in his book, though, is when he got back on Earth and started wearing shirts and pants again, he broke out in skin rashes because his skin was not acclimated to having any type of cloth against it.
Okay, now let's go into the future. 2024, who knows exactly when, we're going back to the moon. The first woman could set foot on the moon sometime in this decade, and 2030, sometime after 2030, we've targeted Mars, the red planet. And so the question is, what do you foresee with the space program? Some people think, for example, we should go to the moon first and then launch off to Mars. Elon Musk says, no. Why not simply do it in one jump? One jump, explore Mars. What are your thoughts about which way the space program is going, and what your thoughts are about the Mars program?
Well, I think for sure Mars should be the ultimate destination for our astronauts. There's no question that there is quite a bit of potential eventually for permanent habitation on Mars, for being a self-sufficient planet at some point. But there's always been this ongoing debate on whether or not the moon is a necessary stopping off point. I think there are good arguments on both sides of it. The fact of the matter is, of course, the moon and Mars are very different. You have 1/6 gravity on the moon versus 1/3 gravity on Mars. So right off the bat, there is that difference in your mobility. The moon has no atmosphere and Mars has an atmosphere. So the same type of life support systems and spacesuits that we used on the moon would not necessarily operate on Mars.
Robert, unfortunately, we have run out of time.